Welcome, I'm Bill Wake. We're here working on a programming language called 10th. It's a subset altered of 4th. And the real reason is I want to do some assembly language programming and try out a method known as threaded interpreters. So today I think we're going to get to that true threaded interpreter. We might take a detour and do printnum first because we were close to it on Thursday last week. But I think we'll get there. Whoops. First, I want to say I'm not going to be here this Thursday or any of next week. I'll be returning a week from Monday, February 26th. A week from, yeah, that sounds right. Okay. So here's our interpreter. It basically it's that thing walking through the list of methods in the secondary interpreter, or in the secondaries. And the core of it is that interpreter loop. We load X1 from X20, the virtual PC. We increment by 8, so it picks up the next word down. And then we branch, BLR is branch procedure call, basically, through the register X1. And when we get back, we branch to the top of the loop and keep going. Eventually, we'll hit an into D, and then we'll do the return. I think we can get rid of that branch to the loop, L interpreter loop if we're willing to make everybody do that call instead of a return instruction. So we'll look at that at some point. But my real concern is this isn't exactly right. And let me show the picture. And we may have realized this when we put it in and just kind of slipped out of my head. We may not have, I can't remember. You get so buried in things. Two problems. We're missing a level of indirection and we don't do recursion yet. We might do it, but haven't tested it. Okay, so if you remember our primaries, they have a header, and I've skipped the first two cells, and I've got the third cell is the address of the code, and so that's why the start2d points down to that code, and push points to its code, and so on. Now, when we have our secondaries, their method they refer to as start2d. So they're not referring to themselves, they're referring over there. And then they have the methods and sometimes extra parameters that come with them, like push needs a number to push. Now, if you take a look at our tests, what we did was we didn't point to the top parameter, that first header cell there, that points to the code. We pointed to the code itself. So here's from one of our tests, our real test on the secondaries. Notice it's loading the addresses of add to, start to, push, and so on. And it's not loading the address of the header cell that points to them. So when you go back to our interpreter, we have one indirect load where we load the cell from the secondary, but we never load the thing that the secondary points to. So that's the piece we're missing. And I think once we have that, we are truly a threaded interpreter at that point. Right now, we're sort of well, basically, you can only call primaries with this approach we have, I think. Well, I'm not sure. You might be able to call secondaries, but we'd have to see. Okay. I think. Let's see. Yeah, that's good. All right. So I thought we'd start with printnum. We had some things on our dependencies. I think we can improve that a slight bit. I think it'll speed us up to not be quite so, I don't know, have to worry about it every time. But we'll do that. We'll do the print numeric, and then I think we'll move this line up to do the indirection. I hope we can get that done today. And the if is needed to test recursion because you need to have a terminating condition. So we'll get that there too. All right, but the macros, I think the real thing is when I look at core.macros, it's nothing to do with our core in the core of our 10th language or anything like that. It's really sort of things we wish the assembler already had as instructions, basically. So I'm going to rename this to assembler.macros. And then just to let it be sort of everybody's. Now, okay, so we're going to have to find the references to core and make them references to assembler. Let's see. So is that find? Yeah. Core.macros. Okay. And let's do it. Is it? Nope. Nope. Oh, Control Shift or Option Control Command. Okay, we're going to replace core.macros with assembler.macros. Okay. And then the question was, well, a question was, do we need to include these in the make file? And I think the answer is we do. Everybody, if we were to change those, then anybody who was compiled with the old one should change as well. And so I think we better leave them on there. Okay, but now I don't think macros should include this set of macros. I think anybody who includes AS unit, I think basically assembler.macros should come first. Okay, so let's move that up. And we have the AS unit 1. All right, I'm going to save all these. Make clean. I took off the ones off AS unit, so if anything blows up, we'll look there first. Some test doesn't include core. Okay, yeah, there we go. C-like tests, probably any of the tests. Okay, so I think everybody's job is to include, every S file's job is to include assembler.macros. Good. All right. Let's push that. Good. Okay. Now I don't mind seeing all these. Not that big. Okay. Let's go to do. Okay. So, well, what we did was we renamed core.macros to assembler.macros. Every .s file requires this first. Okay, cool. Okay, print numeric. Well, that's going to be C-like, I'd say. Let's move these over here. Okay. I'm not gonna possibly regrettably. Well, yeah, I think the test is going to be in a unit test demo because I feel free to throw those away. Okay, BL print number. Let's find that thing. Print number move 13, BL printnum. It's already in C-like. Yeah, okay, doesn't do anything. All right, so the unit test demo, print number. So it does run, and actually we had it in there. Notice print number doesn't really do anything. Okay, so that's okay. I mean, okay-ish. We want print number to be, well, it's going to call print, and it's going to call deck to string. And once it does those two things, it's practically done. Okay, so we're calling other things. So we're going to use our prologue and epilogue. Well, I guess we had a red already. All right. Okay, and then printing a number, we'll do our deck to string first. So the input is just the value to convert, which we already have in X0. Okay, so let's branch down there to deck to string. All right, we get back a pointer to the result, and we can't call it twice in a row. Okay, I'm gonna make this highlight a little more. Note, how about warning? Okay, a little more explicit there. Okay, and then print, it just takes the address of the string, which is what we just got back to X0. So this should be, if we'd had half an hour yesterday or Thursday, we could have finished it, I think. Okay, so that does a print num. We don't care what it returns. Nothing gets used from it. So I think now we'll see unit test demo should print 13. Boom, segmentation fault. All right. Well, okay. All that optimism. Oh, let's see. I guess if we stop here, well, let's stop at print num. Okay, so LLDV unit like demo.out. Okay. Break set minus b print num. And run. Okay, so let's dump this. Select. All right. Oh. Why is that just a ret? Did I not make? Well, I did make because I ran this to get that before. So that blows up. Okay. Unit test demo.out. There it is. Filled, failed. That doesn't mean anything. I thought everything. Well, we touched this. We touched this. We touched that. Maybe I didn't make one of them. What's going on? Well, oh, did I just call? Oh, test print. Let's look for print. Okay, that's the test going to it, maybe? Something's a little weird there. Printnum. Okay, there's the stuff. It's calling deck to string. It's calling printnum. All right, but test printnum was a little weird there. Test start print number. We're calling print number. Oh. I've forgotten what that does. Oh, he puts code in an inconvenient place. Why did that not blow up before? I guess it comes down to where that is. Oh no, he's putting it into data segment and then skipping back to P2 align. Unit tests. Well, loads this, prints it. So it's printing the file name. Am I making printnum call itself? Oh, I didn't call deck to string. Is that what it is? Yeah, thank you. Okay. Print. All right. Yay. Okay. Thank you. All right. So, well, let's add a slight variation there just for fun. Let's at least try a negative like 65585. That's not going to blow up, but it should be interesting enough. Okay, cool. Good. Okay, so I would say make printnum. Okay, where's to do? Okay. Now we're to this. And, well, how we're going to do this? All right, we have interpreter tests. The thing is, our interpreter tests are wrong from the picture, from this picture, because we're not pointing at the header node, which doesn't have to actually live right by the code, but we're pointing at the code. Now we can, I don't know what the right thing to do in terms of labels is. We have to put those headers, because we can't find a way to do a relocatable reference. We have to put those headers in a data segment, and so they'll have to be a little elsewhere. But I think we can do that. All right. So interpret empty program secondary runs yielding. Okay. Interpret empty. Yeah. What's weird to me? Okay. Even there, N2D. Now start2D is okay because we're jumping to that. We're calling a run interpreter. Is that going to be right? No, it's not. Okay. Well, this was us playing around. The address of start2D, the address of end2D. Okay, but I think this is, we want to say it's word address is the term the book I'm building this from uses. I don't know if it's a standard fourth term or not, but the word address is this address of this pointer to the thing. Yeah, let's try that. Good before we get too far into this. Max 64-bit. Numbers. Hopefully they'll tell me all of them. Yeah, minus. Okay, let's take this one. Now, hopefully the assembler is ready to deal with it. Unit test demo. I'll have to take out the commas. That's 1, 2, 3, 4, 5, 6, 18, 19. So we gave it 32. So we're probably okay. Yeah, deck to string. Hopefully we never try to create anything bigger than what we have, but we don't know. That's why we're running. All right, make. That looks good. 922337720. 922337720. 3685477. 6854775 Good. And now we make one bigger. Now I think this should be okay. No, it's not going to be okay. I don't think, because our negate is going to yield the same thing back. That could be. Oh, they don't support it. Let's try 7 and see if they do that. No. Okay. Let's do this. And then, is it neg x0? I think. Sub x0 gets x0 minus 1. I guess we got to neg it first. Put in the most positive number, negate it, and then subtract 1. X0, 0. Okay. We used it somewhere. Oh, we used it in our deck to string. Oh, wait a minute. Didn't we just see it print that? Here's 655 922 3372. Yeah. 807. Oh, I got too many. Oh, maybe I did that before too. Okay. Yeah. All right, and let's try one more, or yeah, one higher. Add one to that. Because I think what happens is when you negate that, you get itself back, and so we get some weird stuff. Yeah. I'm kind of, well, let's take it as a to do. Okay, that's 807. 808 blew out or got weird. It prints a minus, and then stuff's just out of range oddly. It's probably taking a negative because it does the negates it. It should still get negative that giant number, and then when you divide by 10, you'll have a negative number for the byte. You'll add quote 0, but you've been so negative you're going behind. You're going below 0 at that point. But I'll make a to-do note of it. Fix deck to string on most negative 64-bit number, which is there we go. 8. Okay. I don't want to leave it forever, but it's something like I could see running into that at some point. But I've also run into real systems that screw this up, not on 64-bit, but either 16-bit for sure, and I think maybe 32-bit on at least one occasion. This stuff is hard. I know there's a couple articles out there about how to print a number, and it's like it is not easy. There's just little corner cases you don't think about. Like we're not worrying about not a number either. We're doing ints, so they don't have to worry about it. But if we're doing floats, we do. Okay. Yeah. So let's make this one happen. So empty. Yeah. I mean, we don't. I'm going to make this L empty. I don't want these. I don't think it matters for the tests quite so much, but it means we've exposed a symbol that's kind of floating around that isn't really needed. Although it's not declared global, but I don't know, you could probably still get some trouble from it. Okay. This regrettably is not something we can do anything about. But what we need is we need those addresses. So this, in some ways, this is the header stuff. I'll call it a pseudo header. It's a quad. We'll put 2 quads in. Okay, now this would normally be the header that's at the front of your code, but we're going to have to put those addresses. Yeah, well, this changes things a little. Okay, so this empty we've populated with these 2, it's not the right one. We need to get the address of the pseudo header. Okay, so let's hold this down here for a moment. L pseudo header. Okay. If we load address, we load the pseudo header's address, and then x1 gets the address of start 2D, x2 gets the address of end 2D. That's good. Then we store x1 gets x0. That's fine. Okay. That puts start 2D here and end 2D here. All right, but then we need this quad to be pointing at those. So let's do another load address. X0, well, we can load address x1, and now we want L pseudo header. No, we want L empty. And we got to make these point up here. Okay, so our first one is we're going to store x1 at x0. Let's take -8. No. Let me reload this just so we're really clear that what we've done. Okay, so we're going to start at the pseudo header. We're going to put empty's address there, plus, and then auto post increment it. And then x2 is going to be empty plus 8. So, oh, maybe I'm okay. I've already auto incremented it. No, I'm doing that still wrong. This is x1. L pseudo header. We loaded the address of the pseudo header, and we're going to store that in x1. Okay, let's see. So x1 is L empty. All right, so we're storing x0. This increment doesn't matter. Okay. All right, store x0 at x1. So x0 is the pseudo header address at x1 quad. Increment x1, so we're pointing at the next one after empty. Add 8 to x0, so now it's pointing at one word past the header, the first one. Okay. And then store that there. Okay. I think this is correct. We're storing x0 is the address of that, and then the address into x1. Okay. So yeah, so this is that double indirection we want. Now, x0 empty, what's empty? Oh, that I changed the name. L empty. L empty. Okay. Now, with luck, this should blow up. It's It's going to be that kind of test. Boom. Okay, that's good. Because our interpreter does not deal with that. Okay, so where's the interpreter? Here's the interpreter loop. Okay, so now we load X1 gets the contents of the virtual PC. So he's pointing into those secondaries. So he picks up whatever that address is. And right now he jumps to it. So in our test terms, he's jumping here, which is not code. It's a pointer to code. So we're going to need to load that up again. Okay, so I think what we need to do is, and I'm not sure if we can do this like this, but I want X1 to be contents of X1. Okay, assuming it'll do that. I'm not trying to increment anybody. I'm just trying to get the contents of that cell. Not sure about what started L empty plus 8. Let's make sure. Hopefully it's the pointer to 2D N2D. Okay, so L empty plus 8. So X1 points to L empty. We store pseudo headers address there. Now we add 8 to this X0. So now we're talking about this address because this is L pseudo header. This is L pseudo header plus 8. And then we're storing that revised one into X1, which is now bigger, is 8 further. So I think we're pointing to the address that points to N2D. Okay. And then if I got this thing right, we load whatever the virtual PC points to. That should give us the address of a header containing an address of a routine. So we load that in directly and we get that. I'm not quite sure. Sometimes some instructions are restricted about having themselves on both sides of the, on the left and the right. So that's my one little qualm here. Because we're destroying X1, so the original X1 here. We have incremented virtual PC, which I think is the correct stage. All right. Now this interpreter empty should pass and the other one should fail. Oh dear. Okay. Okay, let's look up LDR and make sure my understanding is correct. Is this, okay, here's LDR. Register offset PC relative literal. Well, I believe this is register. 64-bit. So load XT from indirect with an option to shift it. Okay. One option is set to general. Option is 0 then L. Okay. Oh, here we go. For the 64-bit variant, the shift amount optional only when extended, not LSL. It's permitted. Okay, we're not using that aspect. Should I use load address? Ooh, that's a good question. I don't know. Where's assembler macro? Address. Ooh, good point. No, that's to get an actual location. We're loading from a register to a register, so I don't think that's needed. Because we're not trying to embed a location. It's already in what we loaded here. So I'm gonna run the debugger Okay, so interpreter tests. Okay. Break set minus B to, what do we call it? Interpret empty program. And then I think we'll break on our interpreter too. Actually, even L interpreter loop. We can't do that. I think because it's a local label, I haven't included it in the output file. Start 2D. Okay, so we'll run. Wow. Okay, he prints interpreter tests. Okay, he's stopping at the breakpoint. All right, so I guess let's get down to the interpreter since that is what I changed the most. Whoops. No, continue. No. Oh, boom. Oh, we're dying early. Okay. Bad access. UDF 4024. We've got, I think we have this stuff in the data segment, right? Data, text. Okay. Well, that's at least something. Run it again. Step. And I know there's a step over. I did figure out how to do memory, but I didn't write it down. Unfortunately, my memory is not good enough. Okay. Well, looks to me like we're in string print. Oh my gosh. I don't think I'm gonna. I don't want to go through that whole loop. That's test start. Can I say 10s? No. Well, at least this time I've put the table in the data segment, so at least it has some chance. I did pit to align 2, and these. I do wonder, is 2 right? Well, 100 is 4. Let's align 8 just to make sure. I'm going to put another label in here too. Just debug. Okay, so we changed the alignment and had a debug. Let's quit. Yes. Make. Yeah. Um, okay, I think we can run there. And we have this already printed and we have this already printed. Okay, that's progress. Okay, add ERP. Okay, there's our load address. Where's debug? Okay, so yeah, we're looking at the state of things now. So we should be able to see, well, let's look at X0. Okay, so it should be the pointer to empty +8, which should be here. Did I put anything in here that was mem? There it is. Okay. I don't remember what these mean. And then 4030, well, at least I can make it 0. I think I screwed that up. $40.30. Two's not enough. They use 16. Well, I was thinking if your addresses are 8, P2 aligned as powers of 2, right? So 2 to the third is 8, and we're doing 8 bytes at a time. Oh, this -8. Okay, I'm gonna have to figure out how to do the read, but I think we're, if you're at an 8-byte boundary, right, then it should be fine to put a whole word at that point. All right, mem help mem read. I guess S size in bytes. I don't know what I did. F format. I think I'm saying format string. I imagine if I delete it, I'll get a reasonable approximation. No. Display format cost. Okay. Okay. Interpreters, test. All right, equals, well, see, I want something that looks like it's pointing to 4030. That's backwards 4028. 10000004028. That seems like it's pointing somewhat locally. CC3D. Well, this is 1, 2, 3, 4, 5, 6, 7, 8. It must be 16 across, right? Okay, so 10 is 16. So if 40, 30. Okay, so from our code, so I think this is coming up as 4030 because it's where we last wrote to L empty. So 4030 should point to, well, -8 minus 16 is 4020, 8, 16. So I guess 40 something else. 3DCC. Yeah, that could be. Well, we can find out. This is interpreter tests. That's odd. What's use subl 2, interpret empty program. Interpret empty program. Oh, that's some data. Okay, there's the no op. It's the start of the test. Okay, so the address of start2D. All right, yeah, 3DCC, good. So that is start2D. Then we get 3DE4 coming up, hopefully is N2D. Went too far. 3DE4 is N2D. Okay, so I think we have start2D, N2D. And then this is 100004028, which points back here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I don't know if it's pointing. Yeah. 4028 points to address of start2D. Well, I think, yeah, this one is start2D. 1000000 3DCC start2D. Okay. 1, 2, 3, 4, 5. That seems like an odd number of things. Maybe the zeros are there implicit. LDRX1. Yeah, so I'm hoping I pick up 4028 from the first one. Hopefully he's, I think, 1, 2, 3, 4, 5, 6, 7, 8. So I think it's actually this with all the zeros, and then you got to kind of read it backwards. So my read is probably let's read 128 or 96. Okay. Here's start 2D. Here's end 2D. Here's 0428, which is here. And then this one should be 4030. Okay. I think our data looks right to me. So let's I don't remember if we're just at that debug point. So I think let's break set start 2D. If I didn't do that. Okay. Now let's go find start 2D. Okay. So we'll continue. And he's already died. Frame 004028. UDF OX3DC. 4028. Okay, that's in our data segment. Why is he dying there? Wait, he's dying in 422. Oh, we did add our new code yet? Make sure I've saved this. So the code showed X1, X1. Start, interpret, debug, temp. I think that was a debugging name. Okay, there's 3DCC. Like, how did we fail before we got here? We didn't try and run anything. Well, is that true? Maybe our test is not. The data stack is like 10,000, I think. But I think it seems like it's blowing up before it even gets there. So we didn't really look at the rest of our test. Oh yeah, there it is. X0 is the address of L empty. It should not be. It should probably be the address of L pseudo interpreter. No, it should be empty. Let's make sure. Okay, because we want the interpreter pointing at this block, because that's our empty program. Now, is it supposed to be pointing at the start 2D? I think it is. Let's make sure what interpreter does. Well, he's okay. Something's screwy. Yeah, we didn't set up X20. I think this should be setting up X20, right? Because the interpreter expects the virtual PC to be pointing at something. No. Should he be pointing at that header? Because we're going to call start 2D first. That seems wrong. Well, X0 is definitely wrong. This is maybe X20 gets a pointer to a block to go. He should look up the routine. We're calling run interpreter. Maybe that's different. Oh, I see. Okay. Startup method for the interpreter. Word address of the method to run. Okay, so empty is correct. I guess that should be an X0. All right. I'm not sure this guy is right, but okay. So he sets up the data stack. He increments this past the word. Post. No, he's incrementing it before. Yeah, I think this is wrong. No, I don't think Start 2D can set it up. I think when you come into Start 2D, you want to interpret a secondary block. He maybe I'm not convinced he should point to the Start 2D routine or to the word after it, to the block itself. But I think when you come in, normally you're just saying like I'm giving you a pointer to a header, and you should do an extra load on that and start running this routine. And so I'm not sure run interpreter is quite needed. Well, he sets up the R stack pointer X19. Okay, so I think he gets the pointer to the block, because if it was a primitive, he shouldn't just point to it and run it. He needs to point to the header. Okay, so here we take X20 and add that. That seems like he's doing the wrong job. Because Start 2D should be doing that, looking at that header and calling the indirect thing. So I think maybe he's gone too far. I don't think he should do this run interpreter. He should just move X20 gets X0, which seems a little silly. We could have just put in X20 in the first place. X20 gets X0. And then I think he should just call Start 2D the first time. I'll pull both these up. Okay, so I think that's not right, and that's not right. I think for the starting point of the interpreter, I think you should just branch to Start 2D. All right, so now the virtual PC is pointing to lempty, which is the block. We store the stack pointer. The LR. We store the virtual PC, the real return address, and the virtual. And then we we pull up Start 2D out of here. Could set up VPC. No, because this is going to be recursive when we have multiple secondaries calling secondaries. So it's got to be set up outside. That I'm kind of clear on. I seem fuzzy on the rest here. I almost think this. I think we're going to call it recursively the first time. The interpreter is, I give you a block. It could be a primary with the first address pointing to the code. It could be a secondary. The first address points to start 2D, and the rest is a list of statements or secondaries. I give you those things. You should take whatever's the first cell and call the method on that, which is what this thing's trying to do. Okay. I'm going to try this way. Well, first I'm going to save. I don't see a save all. That seems weird to me. Maybe save does the save all. I hope. All right. And I'll do a make clean and make. Okay. Oh, it's sort of progress. Okay. Our assertions are making assumptions, but we did run through, so we didn't blow up on trying to interpret these things, where this one, it's trying to go one deeper on those things and expects to load an address from an address, not just load an address. Okay, so why is this failing? I think that's on the assertions are not right. Asserts, we move x0 to x20. Well, that's not right, because x0 got destroyed by this, so that can't be right. X0 gets x20. Oh, well, that can be. Sorry. I always read these backwards. I think I used every other language I've used has been moved from to, And this one, it's more of x0 equals x20. Okay, so x20 is our global address pointer. It should point to empty plus 16. All right, because it pointed here to start with, add 8, and then it should have incremented on its way out. So I think this should be 16. Address 1, lempty. So the program counter should be pointing 1 past N2D. Yeah, I believe that's correct. All right. Save. Make. No. Yeah. All right. Assert equals. L empty should be the start. Okay. Well, we have technology now. Okay. The reason we wanted to put printnum is we want to use it. Ugh. Okay, so we're going to print what's in. Print what's in. I don't know, that key to help you. str works like I'm going. Huh. Yeah, stores something somewhere. Yeah, that seems more normal. All right, so I'm going to print out x20, and I'm going to print. Well, I want some strings. Actually, I want assert equal to do it for me, but we'll do it here for now. X20 is all right. X1006740338. I don't think that sounds like anything I would expect. Okay. But I do think assert equal can do this. So I'm going to divert. Okay. Yeah, print X would probably be nice. Do I want to fuss with it? No, I don't know if I want to. I guess I'll stop in the test and look. Okay, we get back from interpreter. Let's stop right there. Okay, so we'll run. All right, and then reg read x20 4038. And I guess we got to do our mem thing. Mem read minus count. And we want to start. Will they let us start where we want? Else pseudo header? No. I guess I can't see those yet. Well, we can. Count. From 10. Well, 38. I got 4 zeros there. I got 4 zeros there. 38. Didn't like 20. Well, that's no good. Okay. Reg read x20. Okay. Skip. Step. 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 Okay. Now, x0, well, no, that looks like x1, x1 38, x1 10. Well, there's the 10. Add x138? What is going on there? Add p x11. Oh, I guess that's the... I don't know what 1 means in this context. Is it? It's the page number. So that must be the 40 whatever. 100040 something. 4000. 38, and then we add another 16. Okay. Well, if this is 38 and this is adding 16, I guess we know why it's gonna be wrong. Read x1 48 because I added 10. Oh shoot, we're pushing the virtual PC. Okay. I just think maybe this assertion isn't right. I think it should probably be empty still. I guess that's the answer we saw, but I think that's correct because we call run interpreter. He calls start 2D. The first thing he does is save x20. So even if he touches it, we shouldn't see anything when it comes back. So it should be the same. Okay. X1 should be empty, shouldn't need anything added. I think this is correct. X20 should have been saved and restored to whatever we started at, which was empty. Okay. And then assert equal. Okay. All right. And that's not much to assert. Well, let's just do run. Sorry, save, make. Okay, that one's good. All right. I think we're okay on this one. So the only assertion is really that x20 is properly saved and restored. We're not asserting anything about the stuff that happened. Okay. So I think that's I think that one is good. Okay. I'm going to check it in even though this other one is failing. Is that correct? Yeah, I think it's the test that's failing, but I think what we have is probably worth checking in. I may be wrong, but modify interpreter to do double indirect to get from secondary block to header to code. Yeah. I mean, I probably wouldn't do this to a group. I mean, I wouldn't push wrong code. But I guess I'm willing to risk future me. Okay. Because I do think it is the test that's got to do work. All right. So there's add to. All right. And let's call this dictionary. Maybe add to dictionary. This is, sorry, I saw a bug. Quad 0. We reference push, add, well, start 2D, push, data, and 2D. We'll do some random order because the order shouldn't matter. Start, push, add. One, two, three, four unique ones. All right. And we'll put them in alphabetical order just to make sure they're different. Okay. So now we load the address of add to. I think we want to load the address of add to dictionary. And then to make them in order, add okay. All right. Store x1 in the first quad an increment, store x2 in the second one an increment, store x3 increment, and then the 4 doesn't need the increment. Now, have I done this right? X1 LI dictionary, X0 gets incremented. Okay, so I think we've populated the first dictionary. All right. Twice, X2 twice. Ooh, thank you. X1, X3, X4. Okay. So add N2D, push, and start 2D, but we don't care about X0 at this point. All right, now we're going to load this again. But we need to push differently. Well, maybe X0 should be the other one. Add to. Okay. And we need to load X1 gets L add to dictionary. Okay. So we're going to store X. Well, let's swap these again. I don't know. I'm trying to make them kind of consistent. Okay, so if we store X0, well, I think I just did it backwards. Oops. Okay, to be similar to the one above, we're going to store X1, the address of the L2 dictionary, at X0, plus and post increment x0. But now we need to add x1 gets x1 plus 8 and move it forward. Yeah, I explicitly wanted them in weird orders, but now I got to pay for it. Okay, so x0 needs to be start 2D. So it's really, ugh. Yeah, maybe that was not smart. On my list of things, let's put them in the order we use them. Start, push, add, and 2D. Okay. So we're going to store x0 is start 2D is the one at the first slot. Okay, we're going to store that at x0 and increment it. And then we want to get to who's push. All right. So we got to store x1, x0. Now I think we got to push, we'll put that here, but we got to skip by 16. To our next push. And that has to skip 1. So we can get down to our add. And do this. Except it's 8. Okay. So we've moved forward to add, and then we store that at the next address. And then we move forward one more. Yeah, I miss those PDP-11 modes. You could do that at plus post increment thing on both sides. Although a lot of other stuff isn't as nice. X1, X0, and we don't care about the plus 8. Okay. And push start. Okay. So now we're doing start 2D at X slot 0. Guess I could, not quite. Move forward 1 on the secondary side and move forward to the next routine in the dictionary. That gives us push, store that twice, incrementing by 16 both times. Move X1 forward, and we're on the add routine. We'll store that at the next one, move that forward, move it forward. Okay. I think that feels right to me. Okay. Load address X0 gets the data stack. Okay, so the top of the stack should have the right answer. Okay, and we loaded 1 plus 2. So we expect 3 to be what's in the stack. And we're just loading it right from the variable. We're not loading it from the stack pointer. Okay. So if this theoretically should work. I'm not sure I get it right on the first try, but we'll see. Look at that. Okay, cool. Oh, I feel better having this together. That's good. Let's see. Let's go to interpreter. Okay, our loop's a little worse. It's one more instruction of indirection, but now we're actually using those header cells. So we weren't before. We were just pointing everything directly to the code blocks. And we didn't try a test with secondaries, so you didn't know that that happened, I guess. It didn't matter. If we had called a secondary, it would probably have blown up because it's not, it's pointing to some data area. It's not pointing to an executable instruction. Pointing to a data area that does point to an executable instruction. Okay, like I said, I think we can get rid of this branch at some point if every primary is committed to returning just jumping on its own. Like if they do a return now, we do the return, we get back here and we jump. Instead, I just want to tell them like, don't do a return, just jump here when you're done. This ought to be a public label. But I think that's actually good. And then I could almost, well, maybe I was going to say I could put something in here to print an error if they ran this line. But in another way, maybe I could just let them fall out through the N2D. But I don't know. Okay. But this makes me feel good. I think we've hit the consistent level of what does it mean to be the threaded interpreter at this point. You know, we're doing that little loop-de-doo through the double load and then into the list of code. All right. Well, we're due for a break, so let's take a break, and then we'll come back and do what we have to do to try and make sure we can handle, well, let's make sure we can handle secondaries calling secondaries first, and then make sure we handle recursion. All right, so see you in 3 or 4 minutes. Welcome back. All right, I think we're ready to handle an if statement. So in a way, this is sort of artificial. You'll call if, but in fourth, this is kind of an immediate thing. It does stuff while you're compiling it. So we're going to have to find a way to simulate that. But if you have a macro you're defining, or a word you're defining, you'll say like if, and then some code, and then else, some code, and that gets interpreted right away. It generates some other call. So even though you think you're going to call if, you're actually calling, I've called it if non-zero. But my thought is we would generate a call to if non-zero that evaluates whatever's on the stack. That's the A in the front of the if there. Then it's going to push a code address to the control stack. This control stack is a compile time construct. And basically it's making, because you have nested, we're going to have structured programming sort of stuff, if and while and repeat, one entrance, one exit kind of things. We'll use a control stack to make sure the every if has an end and stuff like that. Now, this code address is going to be the address of the if non-zero, the cell in the secondary that points to if non-zero. So we can go back to that. Well, to the cell after it is going to be the address. And we're just putting a -1 in there for now. Okay, so let's skip down to end because you don't have to have an else. So when you get to the end statement, you've got a bunch of other statements, and then you're going to say pop the control stack into a variable I'm calling patch. And you're going to take the current address and add it to the patch location. I guess I can say that better as address to patch location. Okay, so we push, let's say cell 7 contains the if non-zero. We'll have the if non-zero there. We pushed 8 to the control stack and put a -1 in slot 8. Then we had, more and more statements. We hit number 20 and we say end, and it says, okay, I'm going to pop the control stack, which was 8, and I'm going to take the current code address 20 and put that in the code at slot 8, and then it's ready to, from there you just go whatever's next. If you go to an N2D, that's fine. Your code that's now in slot 8 is going to point down to that. And so if non-zero's job is to take that address and jump to it if the value on the stack is non-zero. Pop the stack and do that. The else, well, we don't, do we have to have it? We don't have to have it, but we probably should have it. The else, you pop the control stack because you've got the code address where you wanted to patch the jump that the if is gonna generate. We're gonna keep that patch one for a second, and instead of targeting the end statement, it's going to target the start of the else statement. So if it's non-zero, it branches to the else. Except I'm wondering if I'm making this if zero. Maybe that should be if zero. If it's false, branch. Yeah, I think that's probably true. Okay. All right, one more look. Yeah, so if it's 0, we're either going to jump to the else clause, 0 being false. If it's false, we're going to jump to the else clause. If there's no else clause, we're jumping to the control stack. So the behavior on the else is pop that control stack, patch the if statement to jump here, and then we're going to push the code, our code address. No, wait a minute. Well, I feel like I've screwed this up. Okay, let's make sure. Go back to if. If we evaluate the value, well, we're not going to evaluate anything at this point. We'll have code to put a value on the stack. We call if 0, which will jump to the next statement, jump to the address if it's 0. At the end, we'll pop whatever the current address is into that patch location. Okay, I think that seems sensible. All right, now the else clause. Oh, okay. Golly, I'll get there. Maybe I should put a little thing on there, but okay. So the else clause, we want to go back and patch the if statement to jump to the else clause, but then we also have to make sure the last statement of the if is a jump because we don't want to continue executing the false stuff. The else clause, we want to jump down to the end statement. So that's that jump on the else clause. Generate the jump, put the -1, well, save the current stack, and then put the -1 there for temporary. And then we'll just go ahead and generate all the else code. Put the current code address to the patch location. Yeah, again, that should be address. Okay, let's make the code you would get for an if then an if end if. Okay. So you're gonna put something on the stack, then you're gonna have something that says if 0. And then you're going to have a -1 for now. And at the end, well, then you're going to generate code for if. Then you're going to hit the end statement. We're going to skip else for now. It's going to take that address off the stack, which was the address of this slot here, and patch it. Now I'll call this and. and then put the current code address to the patch location, and then end is just kind of the address here, which could be, code after if statement. Okay, so that's the code we're trying to generate in the one case. And then the second case, oops. Oh, and that. Okay, the second case, if 0 goes to else, is a pseudo address. Okay, the code for the if. Now the else clause is going to put a jump -1. Well, -1's the next cell. All right, puts that current address to the patch. Okay, at the end, the control stack has patch. That's here. We'll put the code address. And okay. I don't know if I can fit them both on the same. Okay, so this is generates. Yeah, end is the destination for the jump when if is executed. Yeah. So it has to know where to go after the if clause. If you only have an if clause, we're just skipping past the code for the if. Or maybe it's code inside if. And then here, we jump to the else. We have the code inside if. Jump to the end, else code. Well, this is code for else. Okay, in the end. Yeah, I think let's make these different. A little bold italic. Okay. Now, we have a complication, as usual. It's going to be difficult for our test to know what values to put inside those. So I think the solution I'm going to have, well, I was thinking about this for the real situation. We could just count statements or count like lines of the secondary. I think that will work for us. Well, I think it'll work for us in tests, but it's not so handy in real life. So I think it's easier when we're compiling these. I think it's going to be easier to just take the address we're writing to and use that. So when you compile, you're gonna. I mean, it's with Forth-like languages, basically, it's going to generate code as a series. Occasionally, it generates patches, like we're doing here. But there's no like code rearranging or any of that stuff is not part of the default kind of compiler. You could imagine an optimizing Forth compiler or something like that. But for the straightforward one, we're just kind of going through the words we get, call it from the secondary, call it from the secondary, call it from the secondary. Maybe there's a little extra data like the push had. And that's the situation we have. So when we're generating that code, we know where we're putting it because basically it's in our dictionary. We haven't dealt with it yet, but when you get a new statement, they use colon to define things. You get a colon, you're going to say, oh, I should open up a new statement header, a new secondary header, and you'll put the stuff for the linked list in for the dictionary, and then you'll put the address of start2d because you're a secondary, and then you'll have the address where you're going to start pumping addresses of words in. And so we would normally have those addresses directly. if we go back to patch, I don't know if we can. Well, that's what I'm wondering is if we make these numbers, these, let me make this other one the same, sorry. If we make the numbers simple numbers, I want to jump forward 4 statements. I guess when you're compiling, you don't need that because you're sitting there pointing at this address. Like the next place I was going to write was here. I'm going to go patch this address into there. So I think it's different, but we can't get addresses at test time or compile, I guess, assembly time. Okay. Now, the reason I say we can get by without the if else, we could do like duplicate this, test the first one, do if not that, negate it and test it again and do the other condition. We can do that stuff. If the code is the address of a secondary, the end is predictable. Well, it could be any number, right? Because this ... represents, well, it should be 2 ... they represent arbitrary statements. There could be dupes and swaps and adds and pushes and all that stuff inside between the if and the else, or between the if and the end. So the address isn't really predictable in that sense. It's only predictable because once we get to the end, we know where we are. As far as like, where do you write your next word? And we'd say, oh, the next word to write, we know it now. That's the address we should have backpatched it's sitting in our control stack for us to do that. And because the statements are nested, we could have an if inside an if inside an if. They're only going to pop the last one off the stack when they get to the next next end, so they should all work out nicely with the stack. Okay. Now, what we want to do in our test, that's where I'm not so sure what's going to be easy. But what I wish... Well, like, we don't know this, right? If we just put the number of statements in and we're doing it at compile time, then we would have to take this address minus this address divided by 8 would be the right number to put inside. And that seems like runtime computation to work around kind of a test time problem. Okay. Well, okay. This is non-trivial. All right. But I think if 0, like if this thing is false, we're going to jump past it. That seems like an easy primitive to produce. Okay. And I think core maybe not be the right name for these, but it's the name I'm working with. Okay. So I'm going to get a global. Well, I'm going to write a test too, but we'll have a global called if non-0. Actually, it's called if 0. Oh. I don't know. When I have the mic in front of me, my typing is definitely worse. I hope that shut up good. Okay. Let's just put if 0 return. Okay. I guess I could have put that after the test, but we'll go with it. Core tests. Secondaries or subroutines. Well, they're see, when we do the if, we're going to be mentioning old words. Like we've got something on the stack. Let's say we wanted to see if it's well, we got a Boolean condition on the stack somehow. We got a 0 or 1, false or true. And if that's after that if, we could have, you know, we could say after the if, I want you to add, you know, these three numbers, add the two numbers on the stack. And if it's false, I want you to pop one number off the stack. Okay. So, you know, add two numbers, replace it with one, or pop one of the two numbers and go like that. So, you know, that'd be statements you could have inside the ifs or elses. But they're not a separate secondary. They could, I mean, it's not like that's invalid. It's just not what we're going to do. I don't think we have to. If we could only jump one, yeah, I guess if we could only jump one, we would know, like, oh, jump past it, you know. That would be kind of cool. But I think, you know, there's more overhead to kind of create those things. This way we're just right. Oh, I should patch, right. Oh, I got to patch again, you know, kind of thing. And someone's going to have to patch somewhere, you know. Or I guess you could make it so that each one became its own block. The insides of an if became their own block. And then maybe you would do an if else, and then one of the blocks could be empty, you know, or a null block or something. Yeah. I mean, when you get into these implementation things, you definitely have lots of options. Okay. Core tests. All right. So this is, oh, I don't even know what that is. A non-test. Yeah, if they're fixed length, you would know how long the if is, and yeah, it's certainly a reasonable way, and then you wouldn't have to patch ever because it would be like, oh, if true, call the subroutine here. It's almost like two data statements, right? It'd be like, what do you call if it's true? What do you call if it's false? Kind of the same way. Push takes one data word. You know, it's just they'd be pointers to things instead of just raw data. But yeah, I mean, that's certainly a valid implementation. I don't think it's too bad patching, because the patching happens at kind of compile time, which we haven't addressed yet, but it will. All right, so test start, and this is what are we saying? Does not jump for non-zero value. Okay, now we got to make one of these blocks. All right, so that's the text. Oh, test start. Oh, this is that's the code, the test we moved over. Okay. So I think, well, I need some data space anyway. Do I need the routine name? I guess this just gives me something. Oh, that was going to be the header. Okay. Let's do this. Let's do 3. Okay. So we're going to have, I'm going to say if does not jump for non-zero value. Well, it's if 0. Okay, so we're going to have, this is going to be the address of start 2D because this is going to be a secondary. All right, it's going to have an if 0. That's going to have an address, which I'll put a -1 for now. Okay. And then I'm going to do something that distinguishes this. So I'm going to do a push. And do I want an else? I think I just want the N2D at this point. Okay, push. Oh, I guess I need the word value I'm pushing. Okay. And we'll go with traditional. Okay, so all right, and the thing I want to assert is well, 42 is on the stack. I don't know if I should pop. My worry is there's some random chance that the universe could put a 42 on my stack to start with. Let's well, the stack pointer should be one more than the end state. Okay. Yeah, we can check the pointer. Virtual stack pointer moved. Okay. Now we need the code block. Well, this is L. Is 0, 1, I'll say. All right, and this is L. Dictionary for if. Okay. If 0, 1. All right. So first one's got to be start 2D. And okay. If 0, a push, and an N2D. 0, push, N2D. All right. Boy, this is tedious to set up. I don't see a way to do it, though. Well, also, I don't even want this. No, I guess I need a secondary to test this. I was going to see if I could test it without that, but I don't think I can. All right, let's get on to arranging. It's going to look a lot like interpreter tests, so let's start the same way. See, this is where I'm wondering if but it's just so arbitrary. I'm wondering if you could create create one dictionary setup kind of thing for our tests. And they would always have start to D, like we'd put them in alphabetical order or something. Um, but the real thing is, at some point we'll get a dictionary, and then it will become. Then you could really say. I think we could probably define a macro at that point. You'd call lookup, but who cares? It's a test. It's running 12 instructions instead of 4. It's not gonna be perceptibly slow. Your instructions are so fast, I didn't know what the processor runs at on this thing. M2 Mac, I don't know what to tell you. No, the about is not really anything. I guess there's a system report you can run. Yeah, it doesn't really say what speed the processor runs at. Yeah, okay. Well, I'm sure it's darn fast. Anyway, okay. So where you need to push start 2D if 0 push and end 2D. Okay. And I kind of think I've been trying to do if it's not a word, like add is a word that you would write directly in this language if 0 is not, or at least not till we make it 1. And by that token, start 2D and end 2D aren't either. They're sort of system words. They're not really user accessible or needn't be. Okay. All right. So we're trying to push X1, 2, 3, 4 with the words we want. I mean, I could see it. Okay, we want dictive 0 though. Yeah, we're gonna have to think about these tests. I mean, if you had one block and we've got certain words defined, then they're there. But I don't know. You add one, it's gonna mess up the order, and who knows? All right. Okay, so that's the dictionary. Now that's loaded. So now we need to do the other side, which is the secondary block. And it's going to look something like this. Cortez. Okay. All right, so X0 is the block we're writing in. That's this one. And X1 is this dictionary. Okay. So we need start 2D, if 0, and a blank. So start 2D is there. Move forward 1, do end 0, if 0, sorry. We're going to do a 16 because we're skipping, so this one's okay. Then we're going to do a push. And we're going to skip 8. Okay, let's make sure this is right. Okay, so the first cell gets start 2D. We increment the cell we're writing to. We increment the cell we're reading from. Next cell gets if 0. Okay. We skip 2. This one needs to be another add. Okay, that's the if 0. Then we're going to write the push. Skip forward. Oh, we need some data, so we skip forward 2. Yeah, very tedious. All right. Now, the thing we're going to do, I guess we need to push a value on our stack that's true. So we're going to store well, x1's okay. It's not 0. X1 at I guess we got to load our data stack. What is that called? Data stack. Oh, we turn it down to 20. That's still okay. All right. So we'll load our data stack. We're going to load register x19 is data stack. I guess that's load address, right? Load address x19 gets data stack. Store x1 in x19 and add 8. Okay. Would be explicit value put on the stack. Maybe you're right. That would probably be a little safer. Move x1 gets 0. Non-zero. 1. All right. Yeah, a little too coincidental, huh? All right. So x19 is stack pointer, gets incremented when we're done. That's all ready to go. Now we should call run interpreter. I think. Oh, he's interpreting this. Well, I almost think we really could start. We really should load address x0. I think we're gonna. I think we'll just call start 2D directly with this in x0. LF0. X20 gets this address. Okay, because his first thing is this start 2D. All right, and then BL start 2D is given a block with the stack set. All right, and now we want to make sure well, let's load this again. I think we need to, let's put in X1. Put in X0. Okay, so that should load data stack. Whatever's in the data stack should be an X0. we're going to move 42. X1 gets 42. That's our expected value. And then BL assert equal. Did I call it that? No. Equal and test end. Okay. Okay. Yeah, I'm not being very. No, it's data stack because the stack pointer points to the next place to write. So, data stack should now have one value in it. If it has no values in it, then it'll fail. But we put a value on the stack, and then this method should pop the stack, look at the value, and then possibly push a new one on in our case. So we don't have to worry that there could have been a 42 there before, because theoretically it's overwriting a 1. Okay, I mean, you could sabotage it, but I don't think we need to make that happen. All right, let's just for variety put this in up here where it's supposed to be. Test all. Okay. That seems good. I don't know. I don't see anything that tells me if a file is unchanged or has not been saved, but should fail. Oh. Well, that seems. Are we including core? If 0. Okay, this needs to be global. Thought I put that in. Yeah, I did not. Got if non-zero in my mind here. Okay, that doesn't explain them all. Core tests. He's got he's got core. Add to data stack, entity start to D. But he's happy with his 0. That's the weird one. This is core. He's got add. Add to is referenced in start of core tests. Data stack is referenced in start. Start 2D. They're all referenced there. Global. Well, start 2D comes from interpreter. Am I not including interpreter here? I guess I'm not. I wasn't before, so let's look with the make file. Because core tests are now relying on the interpreter, and they weren't before. Core tested out needs interpreter. Add to. I don't even know why I'd be referencing that. Probably a bad sign. Sure is. Adjectives. Okay. Where is... Oh, there it is. Okay, segmentation fault. I'm tired of segmentation fault. Well, we didn't patch our branch location. Maybe that's the problem. Sorry, that's in setup. Core tests. All right. So we did not patch this. Okay. So this, it's really this plus 0, 8, 16. Okay. So we got to move that in. Oh no, that's not right. It's 0, 8, 16. We had to patch. And then it has to be 24, 32, 40. Okay, so load address x0 is elif 01. Okay, then we're going to move. Well, we're going to move something to x0 plus 0, 8, 16. I guess I'll add to that. And x0 gets x0 plus 16. Okay, because we're going to write in here. And what we're going to write is x0 plus 8, 16, 24. X0 plus 24. Zero, 8, 16 plus 8 plus 16 plus 24 is the address we want to jump to. Okay. All right. And now we want to do a store. X1 at X0. Is that? Yeah, I think that's right. It will skip the code if the stack contains a 1. No, I think it'll skip the code if the stack contains a 0 is the... Oh, yeah, I think I've written the code for a non-zero value on the stack. So you have to, like, you're doing the negate, for the jump. If it is 0, then it's a false and we should jump. If it's non-zero, we should not jump, and in which case we'll evaluate. Okay. I'm not sure this is the problem, but it's a problem. And again, I never know if I've saved. Whoops. Okay. Well, all right. Let's look at things after that. Once we do our setup. Kind of reserving debug for that. Well, it's also, yeah, it's you kind of have to reverse the logic when you're doing the jumps and stuff. Okay, so save this, do a make, LLDB, test that out. Break set minus B to debug and run. Okay, ADRP, debug. There's a load address, move one. Okay, I guess I want to, oh boy. Well, I want to see, yeah, I want to see these things. Maybe debug memory is worth putting in too. I'm going to take that one out. Okay, so I want a memory, I want a location to address forward from memory. Quit, yes, make. Okay. Okay. And our mem, oh, I should find that again. Memory read. It seemed like I can just put an address, maybe. Okay. Can I do that? Can I just say mem read and then whoops. I thought it was case sensitive. Okay. There's debug. And well, those don't look like anything. Okay. And have I... All right, let me... Sorry. All right. Break set to debug. Okay. Mem read. And then, I don't know, S. Debug memory. Yeah. I guess it doesn't like to read if it's not allocated, so I'll just try it like this. Nope. Let's load this address in X0 before we get here. Okay. Run. All right. And then we're reg read X0 should be debug memory. Okay, good. Mem read. Can I do that? No. Mem read this. Okay. All right. So the first thing. Okay, so we should have start 2D, if 0 push, and end 2D. Yeah, they should be those addresses. So 3F78. I guess this one's probably not quite current now. Jump to 3F78. Three F3878 start 2D. Okay. Yeah, so there's start 2D. 3F58 is if 0. 3F38, we passed it, push, and 3F90 and 2D. Okay, so the first part of the table looks right, the dictionary table. Now we want to see start 2D, that's there. Then we see 4080. That doesn't sound right. Okay, start 2D. So it should be start 2D, then if 0. Oh, that's this. 4078 is here. That's the start 2D. That's the if 0. Okay. And then somewhere we should see a patched value. If 0, so then the 3F38, that's the one I'm not so sure about. So start 2D, if 0, all right? And then we should have data that we patched with data at load of 0 plus 16. So that's plus 0 plus 8 plus 16. This should be patched with, I think it should be patched with the address. No. Add x1, x0 plus 24. So it should be LF0 plus 40. That's LF0 here. No. LF0 starts. I'm getting mixed up. Here's my dictionary, 4 entries. Then I point to the first one, start if 4080 points to, if that's right, points to this one. Does 4080 sound right? I would have said 787980 would be here. Okay. And then this is the address we patched, 40C0. Oh, that is probably... Okay, yeah, you're right. Okay, so here, 40C0 should be here. Okay, and that goes to 4088, which is 383F, which is the third one. So that should be the add? Am I misremembering? Okay, sorry. I'm losing my context here. All right, that's the start 2D. That's the if 0. If it's 0, we should jump forward to C40. 40C0, sorry. Okay. Otherwise, we should do what 4088 says, which is the push. And then the data for the push is 2A, 32 plus 10 is 42. Okay, that's right. And then C0 is here. Okay, I think our data is set up right. Unfortunately, we're out of time, but we'll pick up here tomorrow. It looks to me like this is set up the way I would expect it to be. C0 should be here, which is the next address we want to jump to if it's false. So we'll pick up there. All right, well, thanks for joining. Tomorrow, 2 to 4:30 and 7 to 9:30 p.m. UTC. First one was EST. Again, I'm off Thursday and off next week, but we got a couple days, and we got the interpreter, I think, basically right. So we just had to get these things pulled together, and we'll take a run at it. All right, thanks for joining today, and catch you later sometime. Bye-bye.